All right, today we're looking at section 8.7, that's simulations. So let's start by looking at a problem. A supermarket is issuing one of 6 different in-store coupons to each customer who enters the store. If the coupons are given out randomly, describe a model that could be used to simulate which coupons would be given to the first 100 customers. We're going to use this throughout the lesson to help solidify our learning. Let's start with a definition. So what is a simulation? A simulation is an experiment that's designed to act out a given situation. We often use models to act out an event that would be impractical to perform, or maybe, difficult, impractical. The objects that you use for simulation should have the same number of outcomes as the possible outcomes for the problem. So basically, we're going back to the experimental versus theoretical, but instead of our experimental being the actual event, we're making a model of that event using other items, things that are easier to work with. The simulations can also be used to model events which outcomes are not equally likely. So let's go back to our supermarket. Let's think about what we can use to model this situation. So a supermarket's issuing 6 different coupons, and they're given out randomly. And we want to simulate which coupons are given to the first 100 customers. So a real quick idea on something, the model, that has 6 different outcomes. I'd say a die. A die has 6 different outcomes. They're completely random, just like these coupons should be. And we need to test it for 100 customers. So customer number 1, 2, 3, all the way to customer 100. Okay, so each number on the die, each face of the cube, represents that number for that coupon number. So customer number 1 is getting coupon number 2. Customer number 2 is getting coupon number 3. Customer number 3 is getting coupon number 1. And we keep on going. Customer number 100 is getting coupon number 4. So you roll and roll and you roll, and then from here, you'll get the experimental probability on which coupon everybody gets. So if you roll it 100 times, let's say we rolled it 100 times, and 2 came up 35 times. So we rolled coupon number 2 35 times. Then the probability of rolling number 2, the probability of handing out coupon number 2 in the experimental world is 35 out of 100, which is equal to 7/20. All right, let's look at another one. See, during the regular season, Keisha has base hits 40% of her times at bat. Describe an experiment that we could use to simulate her next 20 times at bat. Okay, so maybe we could use a spinner. So we have 40% of her times at bat, she gets a base hit. And we want to simulate her next 20 times. So if we have a spinner and we separate it out, this is 40%. These are base hits. And then 60% is not a base hit. Then I can twirl that spinner, and I can twirl it 20 times to see where it falls. So let's say I spin it the first time, and we'll say that the 40% is blue. Those are your hits. And then the white is not a hit. So number 1, we got a hit. Number 2, we got a miss. Number 3, we got a miss. And we do that 20 times. And that'll give us the experimental probability of her going to bat 20 times and whether she gets a base hit or not. There's 2 examples of some simulations. Think of some others that you can use. There's a lot of great resources out there for learning about simulations and creating more simulations.